In this problem, they give us f of x equals ax squared plus kx minus 3. And they tell us that f of 4 equals 25 and f of 7 equals 88. So we want to use that information to determine the ordered pair ak and write that as an ordered pair for our answer. So what this means is if we substitute 4 in for x, we should get 25. So if we do that, we get 25 equal to a times 4 squared plus k times 4 minus 3. So we get 25 equals 16a plus 4k minus 3. If we move the 3 over to the other side, we get 28 equal to 16a plus 4k. Now we can do the same thing with f of 7 equals 88. We substitute 88 in for f of x, substitute 7 in for x. And when we do that, we still have 88 on the left. We have 49a plus 7k minus 3. If we move the 3 over, we get 91 equals 49a plus 7k. So what we have is we have two equations with two variables. So this is a system of equations. So we have 28 equals 16a plus 4k. 91 equals 49a plus 7k. Now in a system like this, the method that I'm going to use is what's called elimination. I want to cancel one of these, and I'm going to choose the k's because they have smaller numbers. So I'm going to multiply this whole top equation by 7. I'm going to multiply this whole bottom equation by negative 4. When we do that, 28 times 7 is 196. 16 times 7 is 112. And then 4 times 7 is 28k. Then we multiply 91 times negative 4. So that's negative 364. 49 times negative 4 is negative 196. And negative 4 times 7 is negative 28k. So now the k's have the same coefficient in front of them, so when we combine these two equations, the k's cancel out. So we have negative 364 plus 196. If we combine the numbers, we get negative 168. We get negative 196 plus 112. When we combine these two coefficients, we get negative 84a. So now, to get a by itself, we divide everything by negative 84. So negative 168 divided by negative 84, we get a equals 2. So now, all we need to figure out is the value of k. And so we can use any equation we want up here, replacing a with 2. So I'll use this top equation. 28 equals 16 instead of a, we put 2 plus 4k. So 28 equals 32 plus 4k. If we subtract 32 to the other side, we get negative 4 equals 4k. So when we divide both sides by 4, we get negative 1 equals k. So put together, we want an ordered pair of a, which is 2, then k, which is negative 1. And there is our answer. And we're done.